Hi everyone, hope you all are fine. This is your VRC Smart Edu channel. Kindly like, subscribe, and share the video with your friends. And today we are going to see chapter 8 of your class 11 gravitation chapter. And this is going to be the part 1 of this chapter. This is going to be the part 1 of the chapter. And here we are going to cover the topic Kepler's law. Here we are going to cover the topic Kepler's law. And the future part of this chapter will be covered in the next few parts. So let us get into the chapter. Okay, first let us deal with the introduction of the chapter. Okay, I have given here few names, right? I have given here few names: Aryabhatta, Copernicus, Tycho Brahe, Johannes Kepler. So first let us deal with Aryabhatta. So Aryabhatta is a person who belonged to 5th century. Actually, he said that sun is the center of the solar system. Sun is the center of the solar system, and all planets revolve around it. And all planets revolve revolve around it. So this was proposed by Aryabhatta. Later came Copernicus. Copernicus said that planets move around the sun in a fixed circular orbit. He said that planets move around the sun in a fixed circular orbit. What? Planets move around the sun in a fixed circular orbit. Who said? Copernicus. But it was not accepted by people. People did not accept what Copernicus said. Copernicus said that actually the planet revolving around the sun in a fixed circular orbit. Later came Tycho Brahe. So he said that actually he spent his entire life in noting about the planet with his naked eyes. He observed the planet with his naked eyes. He recorded the observation. He observed the planets with his naked eyes. Okay, and he compiled the all his observation throughout his lifetime. And these compiled observation was taken by Johannes Kepler. He compiled all the works of Tycho Brahe. Okay, uh, and he introduced Kepler's law. From that, from he compiled all the things that are collected by Tycho Brahe, and he introduced Kepler's law. Introduced what? He introduced Kepler's law. Clear? Actually, this Kepler's law was known to Newton. Actually, Newton is a person who found about the gravitation, right? So this Kepler's law was known to the Newton, which led to the formation of universal law of gravitation. Universal law of gravitation. Okay. So the basis for universal law of gravitation is Kepler's law. So let's get an idea about Kepler's law so that we can understand universal law of gravitation. Clear? Okay. Now let's move to Kepler's law. So what is all about Kepler's law? Actually, Kepler proposed three different laws. First law is law of orbits. Law of orbits. Second law is law of areas. Law of areas. And third law is law of periods. Law of periods. Okay, so we are going to study about all these three laws. We are going to study about these three laws only. So initially we are going to see about the laws of orbits. Initially we are going to look after laws of orbits. Later we are going to look after the law of areas, and later we are going to look after the law of periods. Clear? Okay, initially what is law of orbits? Law of orbit states that, see, actually, imagine that this is the here is your sun. Here is your sun. Okay, this is your sun. Here is your sun. Okay, So law of orbit states that the planet will revolve around the sun in an elliptical manner. So planet, first let me write the definition, later we'll try to understand. Planet revolve revolve around the sun in an elliptical manner, in an elliptical way, where sun is situated at one of its focus. Okay, see, here somewhere in the outer edge I'm showing, no, with the pen, with the pen I'll be showing. See, with the pen I'm showing, no, this is the orbit, right? This is the orbit. Here only the planets will revolve around the sun. So here somewhere else a planet is there. For example, here the planet can be somewhere else, a planet is revolving around the sun. But what they are saying is the planet will revolve around the sun in an elliptical way. It will not move in the circular way. In an elliptical way it will move like this, in this way. It will not move in the circular way like this. It will move in the elliptical way like this. Clear? And one more thing is sun will be situated at the focus. So if it is a ellipse, this point and this point are focus. This point and this point are its focus. So either one of the focus, the sun will be lying at either one of the focus. Okay, so for example, this is your S point. This point is where your sun is lying, right? So that is your focus. Clear? So that is what your law of orbit states. So now let us see this diagram and read more about this diagram. Okay, read more about this diagram, know more about this diagram. Clear? Right. Okay, so just listen carefully. This point I am considering as S. Okay, this point can be your S dash. Okay, and this point is, I am going to consider it as P, and this point I am going to consider it as A. Okay, so now here this is your some point. You can consider some other points also. This is B and this is C I am going to consider. Clear? Now I'm going to name the parts of this. So this, your PA is nothing but, your PA is nothing but your PA is 2A, which is your major axis. Okay, your PA is your PA is your major axis. Major axis. Okay, your PA is your major axis, and your PB is your minor axis. Minor axis. Okay, your PB is your, sorry, not PB, your BC. Your BC is your minor axis. This part BC is your minor axis, which is 2B. Okay, if it is whole length is 2B, this is the center, right, from the origin. This measurement is equal to B. This measurement will be equal to A. Clear? Then OP is equal to OA is equal to A, which is nothing but, it is semi major axis. It is semi major axis. And BOB is equal to OC, which is equal to B, which is semi minor axis. Semi minor axis. Clear? This is semi minor axis. And your S and S dash, your S and S dash are your focus, where your sun can be lying. Then what is this point P and this point A is called as? Point P is called as perihelion. Point P is called as perihelion. Okay, point P is called as perihelion and point A is called as aphelion. Aphelion. See, point P is near to the sun. The point which is near to the sun on the orbit. The point which is near to the sun on the orbit is called as perihelion. So P is near to the sun. The point which is away from the sun, this is a sun, and point is away from the sun is A point is away from the sun. That is called as aphelion. Clear? The difference between perihelion and aphelion. Got it. Right. Now let's move to the second law, that is law of areas. Okay, first let me write the statement as before, and then let us try to understand the statement. Okay, so law of area states that the line that joins the sun, the line that joins the line that joins any planet, any planet to sun sweeps equal area in equal interval of time, in equal interval of time. Okay, what does this state? For example, I told your sun will be present at as one of the focus. So this is your sun. For example, imagine this is your sun present at one of the focus. This is your sun. So the area swept by the sun, any planet can be present. So this is one planet. So this planet is displacing from here to here. The planet is displacing. Initially the planet was here, finally the planet has displaced to this position. So the position when we connect with the sun, the line that joins any planet to the sun, so this line, okay, this is a line that is joining the sun, connecting the sun. So this is the line. Okay, and again the sun is, again the planet is being swept at this position. Then what happens? Here also the line will be joined. Okay, this is the area swept by the planet. Okay, this is the area swept, right? So the area swept by the planet which is connected to the sun, joins the sun, will have equal area and equal interval of time. For example, the area moved by the planet is A and the time taken is T, means the same area will be covered here with the same interval of time T. Okay, so this can be written as derivative of A by derivative of T will be equal to constant, which is nothing but this is your aerial velocity. This is nothing but your aerial velocity. Clear? Aerial velocity. Clear? Some small interval of time we are taking, and if the interval of time is small and the distance will also be covered will be small. So this you can say. And one more thing is that, for example, this is your perihelion and this is your aphelion, right? So if the planet are moving near to the sun, the planet that is moving near to the sun, okay, 1 minute. So the planet that is moving near to the sun will have the velocity high, so the speed will be high. Okay, they move faster, they move with higher speed. Okay, planet near to the sun move with higher speed, move with higher speed. Planet far from sun move with lower speed. So these are the things you have to remember here. Okay, right. Now they are asking you to prove the Kepler's second law based on law of conservation of angular momentum. So your angular momentum is what? Your angular momentum is denoted by the letter L. So this is your angular momentum. You have to show that Kepler's second law is based on law of conservation of angular momentum. For that, what I am going to do means, I am going to take the sun is one of the focus. This is your sun and it is one of our focus, and the planet is sweeping certain area. This is, here is a planet, It is sweeping for certain area. It is sweeping for certain area. This is the area it is sweeping, right? So let me name the planet. First initial position as P and final position as Q, joined to the sun. And this is the area covered by the planet, and R is the distance swept by the planet. Okay, see, it is a R is a distance swept by the planet. You know what is R? R is a distance between the planet and the sun is R, right? So R is a distance between planet and the sun, right? Okay, since it is in the triangular shape, see, it is in the triangular shape, right? It forms a triangular shape, so we can say that our area is equal to half into base into height, right? It is like a triangle, so we can take the triangular area, right? So I can say that the area is equal to half into base into height. So we are taking a small area, right? Initially we took only small area, so derivative of a. So we are taking only small area, right? So this is your derivative of a, small area only we are taking. So small area means surely small interval of time dt only. So here it is traveling with certain velocity, is traveling with certain velocity in small interval of time. So I am considering the base to be as, I'm considering my base to be as v dt, derivative, right? So v into dt into height, I'm considering it as r, right? So now what I'm going to do is I'm going to keep that velocity everything as it is. This t alone I'm bringing here. All are in multiplication, so easily you can bring, right? Da by dt is equal to 1 by 2 v, 1 by 2 vr, we get 1 by 2 vr we get. Now what I can do, I am going to multiply and divide by mass. I am going to multiply and divide mass. Okay, what do I get? What do I get? I get dA by dt. dA by dt is equal to half VRM by M, right? So now what we will get? We will get dA by dt. dA by dt is equal to VRM by M. What is your angular momentum? Your angular momentum is L is equal to VRM, right? This is your angular momentum. So you can substitute L here. So angular momentum is vector quantity. So you can write dA by dt. dA by dt is equal to L vector by, sorry, here 2 should come, right? So here 2m. Okay, so this is what you need to prove. M is the mass of the planet here. So where m is equal to the mass of the planet, because mass of the planet is also involved, so only we are multiplying and dividing it by m. Okay, m is the mass of the planet. So this is really important to remember. This is important to remember. So Kepler's second law is based on law of conservation of angular momentum. So
Clear?
loss of periods is
Okay.
very easy. So if the planet has to travel, it requires certain time to travel, right? So we can say that according to law of period, the square of the time taken for revolution is directly proportional to the cube of the semi major axis. It is equal to the cube of the semi major axis traced by the planet. Clear? This is a very important thing to remember. Okay, this is very important to remember. So now let us try to solve a question with the help of this. So now just I'm going to read out the question. So the question states that a satellite, a satellite A of mass m is at a distance of r from the center of the earth. Satellite B of mass 2m. So satellite A is of mass m and the distance is r. It is given. Satellite B of mass 2m at a distance of 2r from the center. The ratio of the time period is given. So time period, you know, is time period of A, for example, is directly proportional. Square of the time period of A is directly proportional to the There is semi major axis, that is a cube, right? So a cube, normally what is a formula? T square is directly proportional to a cube. This is a formula. So here what will be there? The time period of a satellite will be directly proportional to r cube, because the distance is r. Semi major axis is nothing but distance, right? Okay. So mass is not at all required for us because it is not dependent upon mass. And satellite B, time taken by satellite B square will be directly proportional to 2r cube. Now what I'm going to do is they're asking the ratio of the time period. So TA by TB will be TA by TB the whole square I can write, right? Whole square will be equal to R by 2R the whole cube. Correct? Okay. So now if I bring the 2 here, it will become into square root, right? It will become into square root. So I can write it as, see, R and R will be getting cancelled. So you will be having 1 by 2. So TA by TB will be equal to square root of 1 by 2 the whole cube. So 2 cube is nothing but 8, right? 2 cube is 8, so I can expand that. So what happens for me? TA by TB will be equal to square root of 1 by 1 cube is 1 by 2 cube is 8. So 2 cube, that is 8, can be written as 8 can be written as 2 root 2, right? 8 can be written as 2 root 2. 2 alone you can take outside. So root of 1 is 1, and 8 can be written as TA by TB can be written as 1 by 2 root 2. 1 by 2 root 2. Okay. So you can write it as, they are asking the ratio. So since they are asking in ratio, you can write it as 1 by 2 root 2 or 1 is to 2 root 2.